Mathematics tutorial with Emma.
So that still takes us back to the concept of complement set. So let's say this is set B. Let's find the complement of this set B. B complement will be, remember that you go to the universal set and remove all the elements of set B. So 1 and 5, I'll remove 1 and 5. I'm left with 2, 3, and 4. 2, 3, and 4. Now, look at set A. There are elements there. In set B, there is no element there. Now, those elements that are not in B, where are they? Look at this element here, 1 and 5. The elements that are not in set B, where are they? They are in the universal set, which is 1 and 5. And so we say that the complement of this set B are those elements in the universal set, which is 2, 3, and 4, that are not in set A. So that means that those elements that are not in set A, what are they? 2, 3, and 4. Those elements that are not in set B, they are in the complement set 2, 3, and 4. So I said those elements, B complement means those elements that are in the universal set 2, 3, and 4. And of course, those elements 2, 3, and 4 are in the complement set. And actually, 2, 3, and 4 are not in set B. 2, 3, and 4, they are not in set B. So elements that are not in set B, which is 2, 3, and 4, are found in the complement set, B complement. So now follow me. Are there elements in set B? No. Question, where are those elements? They are in B complement. Those elements that are not in set B, like 2, 3, and 4, where are they? They are in the complement set. So, since there is no element in set B, it means it is in B prime. So the relationship now between A and B is that A is a shaded region. Look at it. A, intersection, there's intersection between them. B, B. Now, is there element in B? No. Where are they? In B complement. So that's the relationship between set A and set B. A intersection B complement. No element there. So the elements that are not there are in B complement. Likewise, if I have A, B, this is set A and this is set B. This is a universal set. And I shade this region now, which is B. That's to say that we are only considering the element of set B only. Here is just the element of set A only. So, question is there any element in set A? No. So you have A complement. Since there is no element in set A, means they are in A complement. Intersection. Is there any element in B? Yes. Intersection B. That's what it means. Okay. If I do something like this, A, B, this is set A, this is set B, this is the universal set, and then I shade this thing. I'm shading the outside now. So at this point, the question is there any element in set A? No. Is there any element in set B? No. So those elements that are not in set A, where are they? They are in the A complement. Those elements that are not in set B, where are they? They are in B complement. So the relationship between these two sets now is A complement intersection B complement. So that means that outside now, which is the shaded region we're interested in, is A complement intersection B complement. Or I can also write this as A union B all complements. And this is what we call De Morgan's law, which we'll look at. But I can also write this as this, A union B all complements, such that if this complement enters the bracket, it will change this union into intersection. So you have A complement intersection. As this comes into effect, it becomes intersection. then B complement. So this is complement of sets. This is union of sets. The first one we did was intersection. Then this one is still difference, or complement of sets. Now I'm going to give us a summary of the whole thing in one Venn diagram. In one Venn diagram, if this is set A and this is set B, okay, this is the universal set. This is the universal set, this is set A, and this is set B. Please note, it is important to know that anytime you are dealing with the Venn diagram, you must always start from the intersection. Very, very important. So let me say this is the first point. Let me call this point 2, let me call this point 3, and let me call the outside point 4. So I want to name these 4 points. Very simple.